All right, this is a part two of the GitHub and Git discussion. So, what is GitHub? I mean, GitHub's been around for a good long time now. It's not the only managed Git services out there. There's Git Labs and whatever Atlassian's product is, Git something. But there's a number of alternatives, and so this isn't the only one by a long shot. So, but GitHub is certainly probably going to be one of the more Bitbucket is what I couldn't think of from Atlassian. GitLab, those are the main ones, but there's plenty. And then there's some that's sort of embedded as a part of other services like Azure from Microsoft and related. So the point is, what do we get from GitHub? So I'm going to come back to Git remote and all that stuff, but let's look at the GitHub docs. A lot of useful things in here. We're largely though focused on repositories. So how do you create a repository? What do you do with them, and how you can actually do quite a bit of work straight there through the interface. But it's really actually meant to be a remote target, to be honest. So, you're not really going to work through there, restoring a deleted, adding files. But they're really talking quite a bit about working straight through the interface here, and that's not generally what you're going to do. Code spaces is another pretty cool thing they have, where it kind of gives you like a little operating environment and pull requests. But the two biggies we're going to focus on are repositories and pull requests. So, GitHub creates a cloud, web and cloud managed Git peer to remote to and from. So that's its main feature. You can make public or private, and you can certainly start paying the money to get different levels of service, and that just goes up through the stratosphere in terms of how much you need from them. But it can also be used to facilitate collaboration around a project, and therefore it can become a hub or nexus for that project. So I always sort of say, kind of the proof of that is even projects like Django or ASP.NET, they live in GitHub. So Django itself lives in GitHub. This is it. This is Django. Or ASP.NET core lives in Django. The project, the stuff you install, the stuff you use, lives in GitHub. Doesn't live in Django. .NET lives in GitHub. Now, it's a Microsoft product, so that makes sense. But Django lives in GitHub. I wouldn't be surprised if Python lived in GitHub. Okay, it does not live in GitHub. I wonder where Python lives. Python source code GitHub. I don't know why. Python lives ostensibly, certainly C Python, which is an implementation, lives in GitHub. So I know I'm doing it for emphasis, so I think you get me. These major, significantly impactfully running the world of information and information services live here. So this is, and it's interesting because, Microsoft bought this thing. It was its own entity. And so the world as we know it lives in GitHub. So why not us? So I was starting to take you through a guided tour of the universe. And I say note, not all GitHub services are free. So some of these are going to seem pretty nifty, but they obviously come at a price. I mean, to be able to have organizations, I pay them a little bit of money myself. So repositories pull requests, but there are other neat things, and let me just keep on going through them. Things for collaboration. The code spaces are pretty cool because it's a way to kind of set up a quick little proof of concept running space. But I think you're going to get into the territory of paying the money there. Repositories, if you want them to be private, I think they give you one private repository gratis. But as a student, and this is what education.github.com is all about. As a student, though, what's just happened to me all day, they really do want you, and I'm logged in, they do want you to know that, there are a number of features available. This isn't looking as good because I'm logged in, but there's a lot of support that they'll give you for students. You can get your student developer pack. There's supports for me to set up a classroom. Although I don't like the way that they handled the repositories, and I would get flooded with them, so I backed out. I didn't like it. But anyway, I mean, they're really here to support you as a student as well. And I'm recording this video for students. Pull requests and all that. GitHub Copilot. So GitHub Copilot is your Chat GPT. It's not Chat GPT, but it's the same concept. It's basically based off of a large language model. It's got a learning bit that kind of gives you some sense of how to do really extensive code completion and code suggestions. And so it's it's a lot of automation to make things easier and more reliable. It's not too different than the fact that, if you fly from Amarillo to Dallas, the commercial service that you're participating in with Southwest or American or what have you, that plane's being largely flown by automation with some key oversight and interventions from the pilots along the way. So, it's not radically dissimilar. So that, that's there. There's a way to set up discussions and help. But the biggest thing we want to talk about is working with repositories to be able to do something called pull requests, which is not a Git feature, but a GitHub feature. And a pull request might be a way for you to take a repository from me and basically clone my repository over to your own area. And then you kind of use the user interface to do this. And then from my area, clone it over. What you actually do is it's called forking. You fork it over to me. You fork it from me over to you. And then you basically start to clone it down to your own area. And then you push back to your own repository. And then you do a pull request to ask me if I'll consider putting it into my repository. So I'm the keeper of the goods. You want to contribute to the goods. And that's sort of how that works. And credit to testingdocs.com where I found this image. So we're going to come back to that, but that's the big deal. The two biggies we want is repositories and pull requests. Depending on who you are, there are some other aspects here that are going to matter. They offer the client apps, the desktop, the CLI. I kind of pointed that out before. But this is not quite the Git desktop. It's the GitHub desktop, which is different from the Git desktop. But they do offer some nice things for project management. And for the 4390 students listening to this, that's a much bigger deal for you because you end up making these projects. And these projects end up giving you some type of, ability to do a little bit of light project management. And we're able to create tables that let us have a number of tasks. Some of these tasks can be turned into issues, and issues can be related to tracking contributions to a code base from other repositories, right? So it's a way for you to kind of keep track of things that happen in a code base or in the whatever you're tracking in the project to these other project management tools. And I will probably make a separate video for this for students who are more interested in this. But basically, I can kind of show you if I were to go. No, I'm not logged in up here. But I can show you what one of these projects might look like. So if I go into here, and this is me, and I can go to my organizations, and then I can look at here, and then I can look into this project. And in this project, we can see, different user stories. This is just a way to organize that task within there. These that have like a filled in point here, the target point or bullseye, or whatever you want to call it. They have been elevated to an issue, in which case it's actually trackable through code. So you end up putting it in here as a task board, or you can have it as a task table, or a to do, or to kind of organize things by sprint or whatever, right? So these are all ways that you can use the projects and the tasks. Clearly the task, you can see, is a way, and it's also connected to these issues. So they're all pretty much one and the same. There's a significant amount of stuff you can do to maintain code quality and deployability with continuous improvement, continuous delivery. Sorry, integration is what the I means. Continuous integration, continuous delivery, which is more or less the essence around what DevOps is, development operations, getting these folks together more. It's really just a ton of automation. So actions are great because there's all types of quality control things, just a chain of events you can have every time you're going to go commit code. To using GitHub as a remote, right? So that's can even put together packages so there's a consistent set of dependencies for your project. And as a nice afterthought, but it's something that for some listeners of this video, I'm actually going to encourage them to do. But GitHub Pages is a way to just develop a little bit of a presence. Web presence based on something that's generated by code you put into the repository. So let's say you want kind of a about this project website to be published separate from just the GitHub community you put around it, then that's possible as well. And GitHub at github.io will make that possible. So this leads to some suggested workflows where you're working through repositories. Sometimes, particularly if you are giving work to me for review, you want to do them as pull requests. So this is something I'm going to get everybody listening to this semester realigned at pretty much now, from the time you're viewing this. Really only the 4390 students are involved. That's an undergraduate course for the projects. It won't make anybody do the DevOps and CI/CD, but if you're really leaning into this, that's what you do. And you could even build a community around your project where GitHub really gives you the tools to do that. And a lot of people, I gave you 3 examples, Django, Python, and the .NET Core, they're all massive, software ecosystems, and they all live, partially at least, out there in GitHub. So let's go back to talking about a pull request and sort of showing what that's all about by making a repository and then catching back up from these Git basics of how to work with a remote. So let's just do that by walking through the steps here. So what I'm going to do is I'll go back out to me, and I'll make a repository. So in the documentation I was showing, they're going to walk you through that. So if you went to the documentation for repositories, particularly through the quick start, you can get a really nice walkthrough for what I'm about to do. So I'm going to make a repository. And you can make those code spaces as well. And of course, I'll call it get demo, demonstrating Git. Now, whether you're public or private has a lot to do with whether you're paying them, right? So if you're paying them, I don't think it's fully unlimited private, but it's still more than I think the one they might give you for free. If you want to add in a README here, now if you stick this stuff in here, this is the difference between, do you start with a Git init on your side, or do you start with a Git init on GitHub side? If I add any of these things in, then I'm not going to be doing a git init like I did in part 1 of this video. I'm actually going to do git clone. And since I was yet to show that, let me go ahead and do this. So I'm going to add in a git ignore. So they're willing to, like I showed earlier, you can find one. They're willing to just help you out here. I'll do a Python one, even though this is not going to be a Python project, just to kind of give you an example. And there's all types of open source licenses you can pick. You don't necessarily even need one. I'm just going to go ahead for the sake of showing you this. Now that I create this repository, I'm actually pretty much ready to go here now. And it's pre-populated with a bunch of stuff. And so what matters then is that I actually can pick up this particular URL, which is what I'm going to use to associate this repository as a remote. But if I clone it, then I'm going to get that stuff all for free. So basically, here they are trying to sell me Git Copilot, but I can download this as a zip. So every time I have people like submit work as a zip, I'm assuming you're doing this, can actually just straight up open it with Visual Studio. I don't think it's going to be code. I can open it up in your GitHub desktop, which is one option. You can work with the GitHub CLI, which isn't too different than working with Git. But I'm just going to go ahead and I'm going to need this URL. And so what I'm going to do is I'm going to clone it, right? So I'm going to go out of this. I'm going to close this, excuse me, folder. And I'm going to open up a folder. And we have a couple of options here. In fact, I'm actually going to close this. If I clone Git repository, this will actually look for that URL. And it's pretty convenient because it will pretty much then facilitate the opportunity for you to clone that, pick a place on your local drive, and have it go there. But since I said I'm going to be working entirely off of the command line here, then I'm not even going to rely on that magic. So at this stage, I want to go into Git here, but I'm not going to call this, although it's going to be a problem because I already have something called Git demo. So let me actually rectify that by getting rid of it. Or at least I'm going to rename it to be called Git demo 2, because I'm about to download something into here that's going to be called Git demo. So let's do it again. I'll open up a folder, go into all my source stuff, go into Git, and then I just want that outermost folder open. And it's showing me demo 2. Don't worry about that. But if I say git clone and I put in that URL, which mind you, I copied from going to code here and I picked up this URL. So if I say git clone, then it's going to bring that in. You notice it called the folder git demo because that's what it's called out here. So the relative path here, so relative to my account, I made a repository called Git demo. And so it's one of the repositories that I work with. And it's relative to my own account, right? So Git demo is, I pre-populated with this when I kind of let it do that. So then if I went into Git demo, it's all good to go. It's got the git ignore, it's got the license and all that. So let me close this because I just want to open it up directly. And that's kind of a slight oddity the way I did it. But I'm going to open it up directly. And we see it's got the .git folder. You might have saw it there. Let's pop over to the file system. Git demo. It's got the .git folder already. We brought that down from having cloned this. So there's the README. There's that license. There's the git ignore. And I actually said, please make a Python friendly git ignore. So all that stuff's good to go. But what's more important is that I actually have this as a remote. So we don't have to say git remote add alias and URL. because I already have this as a remote. Now we can, I'll demonstrate making, doing this a different way and actually making a remote. But for now, if we say get remote, it'll list that we have a remote called origin, which is kind of the default term. It's relative to what we just did, which is clone. What's the origin of what you clone? That's the backstory of why they call it origin. If we say get remote in -v, it'll, v means verbose. It'll tell us more. It'll say, for the purposes of fetching and pushing, we are using this URL. And so all get remote is a way to create an alias that stands in front of a URL instead of having to type that whole URL out. So that's essentially what we get out of the box. So now that we have this, we can do things like get push, get pull, and let's kind of go through that workflow. And I'll do this by showing the website on one side of my screen. Nope, that didn't work. Showing the website on one side of my screen and then showing Python on the other side. So basically, if we put this in here, we end up having, let's have this shared just a little bit. So if we make any changes in here, let's close that and we'll do something to the README. So what I'll do here right now, it's got our commit. I'll go in here and say something like, I can add to the demo. Okay, so now if I say get status, we've got something that's not staged, so we know that. We can do our git commit am updated updated README, and I went ahead and actually updated that. So now if I say get status, it'll go ahead and say your branch is ahead of origin master by 1 commit. So this is pretty cool. So it knows then that I'm locally ahead of the remote here. And so that's what they mean by origin/master. Origin is the nickname or alias for my repo, and then master is the branch that I'm on, right? And you can see it'll show you the branches here. I'm on the website on the right-hand side here. So then if I say, let's look at our slides, what's the next thing for us to learn about? A get fetch will get all the branches and statuses from the remote, right? So if I said get fetch, it didn't do anything because I'm up to date, right? It says there's nothing to commit. It tells me your branch is ahead. So it just got that information. If I use the web interface, which is a bad idea, but if I use the web interface to create a new branch, then it would actually, or make some changes, or this is important, somebody else went and made some changes, then basically I would see how my local version is different from the version out there. And that's essentially what this is about. So then if I said get, so that's get fetch. And then a get merge would mean to take changes out there and bring them in here. And usually get pull does both of that. So get pull does a fetch merge. And so it's far more common to use get pull than it would be to do those two things independent of each other. So a get pull is usually us doing fetch and merge together. So the ones we typically use is push pull, push pull, push pull. And usually you pull, then push. Pull, open up your editor. Great, I'm going to sit down and do some work. Pull from out there. Usually it'll update you if there's some merge conflicts, then it means that you don't have a good strategy for keeping yourself out of trouble with other work. And I can demonstrate that like we were doing last time with file 1, file 2. So I'll actually say file1.txt, and I'll go ahead and say file2.txt. So the idea now is that when I push, I'm actually updating the remote here. Those two files don't exist here, but they are here locally, which you can see they're not even being tracked. So here, if I say git add everybody, git add everything, this is what the A is, and then git commit am updated for file 1 and file 2, then it knows those two files exist, but they don't exist out here. If I said git fetch now, it's not going to say anything though, because there's nothing new out there. That's only going to tell you about new out there. But if I say git status, it'll pretty much say, look, now you're ahead from the remote by 2 commits. One was to change the contents of the README file. The other one was to actually add those 2 files. So if I clear this out and then I say git push, now the U, let's do a help. The U says set upstream. And so what that means is that make sure you reinforce that the upstream, which is what GitHub is who you're partnering with, right? So it's kind of redundant, but sometimes if you make a new branch here and it doesn't exist out there, you'll get a complaint. By setting upstream, you make it clear, okay, I want my buddy on the other end, that is the GitHub repository, to be a reflection of me, right? So then we say, and then origin is the nickname we gave for this repository on the right-hand side of the screen. And then master is redundant because I'm on the master branch, but sometimes it's good to actually make it clear. So if I do that, it's going to basically do a little bit of negotiating. It communicated to the web. It actually told you how much it wrote and how fast it wrote it. It went ahead and said, what changes it's detecting between you and the remote. And if I refresh the page, it'll have file 1 and file 2 there. It'll have I can add to the demo. So these two are up to date with each other. And you'll get that by actually saying git status. So now that you've got a remote, and you can actually add in quite a few remotes. So for instance, if I went in here and said new repository, and I'll call it git demo 2, okay, because I already have one called git demo 2. And I'm not going to add in any of this other stuff like last time. Okay, then I can, so you notice that the screen's a little bit different, but I can still add this guy, and I'll call this git remote add origin 2, and then I put in the URL. Okay, so the command is, if I go back to my guide, git remote add, what is the alias, what's the friendly name I'm going to give it, and what's the URL? Origin 2, that's the URL. Then I have 2 remotes now. So if I say git status, it says that I'm up to date with origin master, but it doesn't know anything about origin 2 because I haven't done anything with it. So if I say git push, this is where the U matters quite a bit. Origin 2 master, then it'll push all these contents up here. And now this is going to reflect the same thing. And then if I get a status, it's going to basically say, I'm good to go with origin master 2. Now, the reason it's saying that is that's when I said this, the U says, well, who are you communicating with right now? And so you set the U to switch channels, right? You set the U to say, oh, I want to communicate with master now. I'm sorry, origin, the regular origin. And so now you said it says branch master is set up to track origin master. Then if I said status here, it says that I'm communicating with origin masters. You can only communicate with one peer at a time. Now there's that GitHub actions that I alluded to earlier. That's a great way to kind of do trickery and get something to be broadcast to a number of repositories. And there's all kinds of fun things you can do. But nonetheless, this is essentially what's going on. Then you can start to even play with branching. But what's going to be far more important then is that you can get merge conflicts. So I'm going to do the reverse. I'm going to have 2 local projects each having a clone. And so let me go back to get demo 1 or regular old get demo. So I'm going to have another thing clone this. So I'm going to clone this from, I'm going to pull this down. I'm going to clone it to a different location. Then we have the potential problem of I can get something that's called a merge conflict. And that would be that something has been changed in 2 different places and it's hard to tell which one's authoritative. So we'll do this by opening up a new instance of code. Let me get this over here. And I'm going to open up a folder. And I'm going to have to put this in just some type of out of the way spot. How about data 2 here? How about we call it GitHub test? And I'll go in there and I'll select that folder. Sure. And then in GitHub test, I'll open up the thing here, and if I say git clone, git demo, then it's going to have now all those files in there, right? So now that I have git demo in here, let's see what we can see. So if I say git status, it says that this is not a Git repository, and I know why, because I need to go down into git demo. Git status, it's going to say it's not a Git repository because it's the .git folder is not there. So here, if I say, let's see, let's go to file 1 here. I am in file 1. Originally, I am in file 1 next, then one of the problems could be I've changed this file in 2 different places. So here I'm going to say git commit. We'll git add so that, well, no, it's already there. So we'll say git commit am. I am updating from the second team. Okay, and then that is going to be the most recent commit, right? So the idea here is that if we go here and we ask ourselves who is the git status, and so the remote is origin master, we'll say git remote -v, and it's definitely git demo.get, right? So if I said git push u origin master, then that gets pushed up to here, and we can see that I am updating from the second team. Okay, so if this guy says git add everybody, git commit am, I am updating from the first team. Okay, and so that goes up here, and then I refresh this. Then, of course, I haven't pushed it. Okay, so then git push u origin master. Okay, here we are. So it says it failed to repick this because it contains work that you don't have locally. This is usually caused by another repository pushing to the same reference, right? And so you need to do a git pull. So it's already telling you, hey, somebody else is there. You guys are trying to write to the same file, which means you're not up to date. And so if I get up to date by saying git pull, git pull origin master, then I'm going to get a merge conflict. And the merge conflict says that, hey, look, I am in file 1 originally, but then the thing you're bringing in is I am in file 1 next. So, like, which one is it? Do you want to accept your change or the other person's change? Do you want to keep them both? If you go to the resolve in the merge editor, it's still just roughly doing the same thing, right? It's basically saying, which one do you want to do? Do you want to accept the one you're in, like the one that's coming in, or do you want to accept the one that you currently have? And so if I accept the one that I currently have and I complete the merge, then I've had to resolve the merge conflict. But that means then that that now if I say git push u origin master, then it's pretty much saying, hey, look, like you didn't actually fully do that. So now I have to say git commit kept my changes, and then git push u origin master. You notice that what this is actually the source control thing trying to help me out, saying, hey, look, I can take care of this for you. That's why it actually took over. But if I push it back up, then it'll pretty much, you've made up your mind that you are in charge, but now you've lost that other person's commit. So the way to do this is to stay out of each other's files, right? So this is only for team 1 to write to. This is only for team 2 to write to. Team 2 is in control. Okay, so now if I say git add everything, git commit am updated from team 1, git push u origin master, up it goes. Go back, refresh. This is only for team 1 to write to. I'm okay, and see, we've already got this problem, right? So we've got a commit that's got actually, never mind. I clicked on the commit itself. Sorry. And then we've got this. So now, if team 2, so this is team 2, does a git pull origin master, then they're going to get all the changes. But see, now if they're disciplined, then they say, yes, we will only work here. Okay. Then we say git add everybody, git commit am. We did some work in our area. Git push u origin master. Then up it went. Up it went. We did some work in an area. Yes, we will only work here. Okay. Then if we go to team 1 again, git pull origin master, they get some updates, but they're not going to play in that file. Great. And there are no conflicts if we stay in our lane. Okay. Git add everything, git commit am. Yes, team 1 is effective. Git push u origin master. Great. Pull this other one in here. And then we'll pull up the Git demo. Yes, we will only work here, right? And they can keep, I think you get the point, I hope. If not, just rewind this video a couple times. You stay out of each other's way by staying out of each other's way. So even in a complex, ASP.NET project or a Django project, let me see if I can open up two things of that nature. It's not a good example, but this is my repository for working in 4390, which is a undergraduate course. So the idea here is, although, hold on, git branch. Okay, so git checkout -b fall 2023. It's actually pretty useful because I actually needed to do this. Git push u origin fall. If I do that, it'll actually try to push my current, it's supposed to fall 2023. Yeah, it'll push this to be a new branch up there. But my point being is that the way I stay out of trouble, and I've got this actually divided up into like different projects. So the way I stay out of trouble is that, well, I'll work in this area and, another team works in this area, right? So you get things kind of divided up by project. You get things divided up by different source files, but you figure out ways to divide and conquer by having a distributed, therefore much more manageable approach to your project. And so even in the simplistic example I used of Git Demo 1 and Git Demo 2, it's still roughly the same concept, right? That you keep things sort of segregated out. Now, if you're by yourself, it doesn't matter as much. So anyhow, let's get back to the tutorial and kind of wrap this all up because there's two long parts here. But I did a bunch of git, remote, fetch, merge, pull, push, all that in that segment. So rebasing is interesting because what rebasing will do is give you the ability to basically move the current spot of where you're at. Remember I gave you that head and tape metaphor. It'll let you move to the current base of your project. It'll let you move it to like a different branch. And so you can sort of move where master is at up to the front of another place. Sometimes people do this by going backwards too, right? So rebasing says move the current live spot or the current active spot in master over to this other previous spot. There's no future spot, right? I mean, no such things exist. So you're usually going backwards. And so you could rebase onto a branch. You can rebase to the upstream. So it gives you a lot of ways to say, I want to move the current head, and you can get this just by saying git status. I'm sorry, let's do git log. We can see how we're out of step with origin master and actually where the head is. So the head is basically kind of where you decide to rebase to, right? So if I could rebase to this particular commit, or I could just rebase to an entirely different branch. So for instance, if I say git branch, I only have master, but I could rebase to that different branch or even a different commit. So it's a way to move that head, if you will. Let's go back to the log. It's a way to move that head around to either prior commits or other branches. And this is what reset does as well. So reset actually clears your staging area and rewrites the working tree to a previous commit. So really they work together. So we can rebrace to a different branch or reset back to a prior commit. And hard actually just says, and forget about what's happened since then. So it's almost like going back a couple of save games and then just starting from, like let's say if I'm going to use that video game example, I get to a hard part. I made a lot of bad decisions. I got to go back to a couple of save games because I'm just never going to get out of this predicament I've gotten myself into. So that's pretty much maybe conceptually how that works. All right, so last but not least would be git stash. So what I'm going to do is, and then we'll call it, this is more than enough. So what I'm going to do is say git checkout b test. So I'm going to have a branch called test and a branch called master. If I say git branch, then Lord. If I'm going to say git branch, then I'm going to have master and test. And it says that the current one is test. It's reinforced by there and the little parenthetical you have out here. So if I go here and say, and I forget which is which, but it doesn't really matter. I think I was supposed to be in 1 here. So if I say something like, I am thinking of doing something iffy here, not sure yet, then one of the things we can do if we say git stash is that we save the working directory and index state as a work in progress on test. And that's for the yes, team 1 is effective commit, right? And so if I say then, going back to the thing, git stash list, then it pretty much says like, look, I have one potential change I'm going to make inside test, but I'm not sure yet, right? So if I go back here and say git checkout main, is it called main? I think so. No, master. Then basically you notice it disappeared, right? If I said git checkout test, it's not there yet, right? So if we went to git stash list, it says we do have that one waiting to see if we want to put it back in there, right? So what I mean by that one is it was sort of like a scratch pad of I'm not sure if I want to have that. And so if I do want to have it, I can say git stash pop and it'll put that back in there. Then if we said git stash list, there's nothing waiting anymore. And so it's a way to say, look, I made some changes, but I got to pop over to another branch. I forgot to look at something. When you come back, you have this ability to then go back to like the scratch pad and say, no, I actually want it. Or I'll go ahead and git stash it again. Okay, and it put that change off to the side. And I could say, or maybe I want something even more iffy. Git stash. Okay. Git stash list. And now there's 2. Right? So then let's actually look at this. Git stash pop help. And so now if you want to say git stash pop, then the idea would be you have that you can put which index off of this list you want to use, right? So you notice that we have 1 and 2. So if I say 1, then it puts something, but it took the first one off the list, right? And then if I go and look at the list, then it still has that 1 in there. So then if I actually said git stash pop here, it would not replace that. And the reason is because we didn't make up our minds previously that we wanted to make that change. So then git stash drop would get rid of that last one that you didn't use. And if you look at the list, now we have none. So you have to go back and look at that again. But basically, when you have that list to choose from, let's just do it again. So I'm going to say 1 git stash. The 1 goes away. 2 git stash. The 2 goes away. Git stash list. We've got those 2 different stashes waiting for us. Git stash pop help. Then it basically says, all right, well, which of these 2 stashes? So if he says git stash pop, then this one right here would be which of those 2 stashes you want to put on, right? And so it's actually considered a stack structure. And as a stack structure, then that means that it's basically going to be kind of first in and last out. So let's go ahead and look up something in the documentation. So git stash pop. I'm just going to pull up the Git tutorial pretty quickly. Let's use Bitbucket's documentation. So we did that git stash. Okay, and then we know that we can do a git stash pop, and it'll put that one down in there. So if we go down a little bit further, we did the U. There we are, managing multiple stashes. So we have all 3 of these. So if we say git stash pop, and this is actually where I blew it. I didn't put that full name in there. So I thought I could just get it with the index. That's why it didn't quite work the way I was expecting, and I wanted to come back and try to do right by you, to be honest. So if I go list here, then it's pretty much saying, well, if you really want this one, I'll copy it. Then I have to say git stash pop and put the correct one in there. That is the correct name of it. Then, but it really should have taken, yeah. Yeah, it's just showing what the change was. That, here, and then let's look at the list again. And we should just have the 1 in there. And if we actually say git stash pop again, then the reason it doesn't actually take over the 2, put the 2 in there, is because we've already used the 1, and the 1 was the one at the top of the stack. So basically, that's how you would be able to kind of, I mean, usually you don't have a stack of them anyway. But basically what you end up doing is this is how you have the ability to kind of change your mind, go off to another branch. All right, let's close out here because this is basically 2 hours worth of video, but I want it to be pretty thorough. So that's essentially most of the basics coming off of, where did you go? This particular, well, that's not the cheat sheet. That's the cheat sheet. So really going through that cheat sheet, this is about as much as I could possibly tell you. The only thing last I can probably cover, and let's go ahead and do that, the last thing that's worthwhile of doing would be, well, how would I, if I, so we go here and we have this get demo. So how would I go ahead and fork something? Well, the problem with forking would be, and let me go back into my repositories, is it's hard for me to show you without you being able to kind of be logged in as a different person. So I could create a new fork, but when I create a new fork, what ends up being the problem with creating the new fork is that it's going to be, it's going to become, if I fork it, it becomes a new repository on my side. And so when I actually asked this thing to fork, it kind of basically was confused and saying, well, I can't fork to yourself, right? So forking really works the best when you go off and look at somebody else's project and then fork it over to you. So this is where I'm actually going to have you rely on looking at their own documentation, because I would really have to come in here as a different user to be able to fork over. So, but I can sort of leave it off with this conceptual drawing here. So let's do that. I mean, we kind of had it up here, but I'll do one last one here. So I failed to fork really because I can't really fork to myself. But let's let the bubble here be Bab repo. And let's let this be student repo. Then let's have the oval here be student local working directory. So when you first ask to fork, you're pretty much saying, hey, take this one and make it so that I have my own copy. But they're linked to each other now because it knows that you forked from this one. Not linked in a way that the student can control this one. It just knows that it originated from this one. So then what you do is you clone. So this one here, in fact, I wonder if I can make like a double-ended. Yes, I can. So this is going to be the fork. Then what you do, and this should be double-ended as well, to be honest. What you do is you, from your GitHub, so this has been cloned, forked over to yours. Then from your GitHub, you're going to clone. And so you have that clone relationship so that your local machine working directory, you go back and forth, back and forth. And then from the fork, you can do, and this is unidirectional. Because you forked from mine, then when you've made some changes, let's make that green, then you can do a pull request. And this is going to have to actually, let's just make an arrow that's actually correct. Let's make an arrow that points in that direction. So then you're going to make what is called a pull request. And so the pull request comes from, you've done all the work. You did, let's put these almost like in steps. So step 1, you did the fork. Step 2, you did the cloning. Step 3, so we'll say step 1 is do fork. Step 2 is clone. Step 3 is push. Step 4, this is the simplest. You usually have a lot of back and forth on your end, but step 4 would be pull request. The idea, and the way the pull request works is you go from your repo branch out to the origin, the person you've forked from's repo branch. So that's probably my best sort of rule of thumb for it. Let me try to maybe make a follow-on separate video for that. But this one's got an hour, so it's a 2-part series. But this is about as much as I could think you'd probably need to know in terms of an overall guidance to Git, GitHub, and all that stuff. So I hope it's been useful to you. And if I need to do any kind of one-off follow-ups, I will. All right, thanks.